Today in the computer lab, we were looking at these demonstrations of the different triangle centers. And what I wanted you to see, and this is why I showed the angles, is that when you change this triangle around so that the angles of the triangle make an acute triangle or an obtuse triangle or a right triangle, it can change, not always, but it can change where the circumcenter is located. In this case, the circumcenter is G. And right now, this is an acute triangle because all three of these angles are less than 90. When I have an acute triangle, as you're seeing here, let me make this a little bigger so I can write here, G is inside the triangle. Now, if I change this and I make ABC an obtuse triangle, I know that this is an obtuse triangle because of that angle right there, which is greater than 90. Now, G is not inside the triangle anymore. G is outside the triangle. It's outside triangle ABC. See, here's the triangle, and there's G. As a matter of fact, let's see, I think I might be able to make it a little bit clearer what's inside and what's outside. Let me see if I can do that by doing this. And I'm going to change it, make it a little lighter. There we go. So there's the inside of my triangle is the yellow, and G is not in the yellow. Now let me try and change it so that it's a right triangle. How about if I do this? It's really close to a right triangle. It's very hard to get it exactly. But I'm going to say that's exactly. It's not exactly, but see how close that is to 90? Well, not only is G on the triangle itself, which is the outside, line segments, it's on the triangle. It's actually at the midpoint of the hypotenuse. So it's on the triangle. Technically at the midpoint of the hypotenuse. So on your chart, your first row was the circumcenter, so that's what you should have for those values. All right, let's look next at the incenter. Here's the incenter. This is made from the angle bisectors. And here are the angles. I provided them for you so you could see whether it's acute, obtuse, or right. Okay? So right now it's an acute triangle. Where's the incenter? Because E is the incenter. It's inside the triangle. I'm just going to go ahead and write. No, I'm not. I'll make this bigger and write it here. So when my triangle is acute, the incenter is inside the triangle. What about when my triangle is obtuse? This is definitely bigger than 90. Where is E? It's still inside. As a matter of fact, no matter where I put this, no matter what type of triangle I make, even a 90, here's really close to a 90, E is always on the inside. So the incenter is always located inside the triangle, no matter whether it's an obtuse, a right, or an acute triangle. So for the row that talks about the incenter and the angle bisectors, this is what you should have. I'm not sure that the order I'm going in is the same as on your chart, so you look on your chart and you decide that. Next, we have the centroid. Here's the centroid. These are medians. Okay, point G is the centroid. Right now, this is obtuse. You see this angle up here, 107? So that's an obtuse angle. So it looks like when it's obtuse, G is inside the triangle. Okay, so we just need to figure out acute and right. So let's do that. If it's acute, let me move my angles to where they're all less than 90. G is still inside. How about a right triangle? Well, this is pretty close to 90. G is still clearly inside. It's not even close to being outside. So again, with the centroid is always located inside the circle, no matter what type of triangle it is in terms of acute, right, or obtuse. So look for the row on your chart that says centroid. And make sure you put inside, inside, inside. Finally, we have the orthocenter. Now I know this can go outside because sometimes the altitude goes outside. So here's my triangle. Right now, these are all acute. So D is inside the triangle. So for acute, it's inside. Oops. Let's see what happens when I make this an obtuse triangle. Well, D is outside. Notice how this is greater than 90, so the triangle is an obtuse triangle. And the orthocenter is outside the triangle. And finally, let me see if I can make this a right triangle. Whoa, I didn't mean to do that. Okay, I goofed up everything there. Hang on, let's see if I can just go back. That works. And make this a right triangle, and look what happens. D actually will be at the vertex of the right angle. So again, when it was an acute triangle, the orthocenter is inside. For an obtuse triangle, the orthocenter is outside. And when it's a right triangle, it's at the vertex of the right angle, which means it's on the triangle. Okay, and that is everything you need to be able to memorize these. Make sure you know them tomorrow.